Good morning. Under the equivalent circuit of the transformer, I'm going to discuss the exact equivalent circuit. So what is the meaning of the exact equivalent circuit? It is if an actual apparatus is replaced or represented by an equivalent circuit, which has the same properties, which means the actual apparatus will be represented, or the process of the actual apparatus will be represented using circuit. Here, this transformer diagram, we have here the primary current, the primary voltage, the secondary current, the output voltage or the secondary voltage, the leakage flux in the primary and the secondary, then the primary turns and the secondary turns. Here, we are going to represent it in circuit. So we transform it to circuit. That's what we call the exact equivalent circuit. Before that, here is prior the prior circuit discussed by the first reporter. So we have here the primary leakage impedance and the secondary leakage impedance. The B1 or the primary voltage, B2 the secondary voltage, E1 is the induced secondary voltage, and E1 is the effective primary voltage induced by the mutual flux. Then the E2, the effective secondary voltage induced by the mutual flux. So E1 and E2 is the output voltage under mutual flux. So yeah. Here we have the exciting current or the losses. We have here the R0 or the resistance core loss and the X sub n or the magnetizing impedance. So under the R0 we have here the core loss current. Under the X sub m we have here the magnetizing current. So in further discussion, we are going to use the ideal transformer ratio. We have here the I sub 1 over I sub 2 or the current ratio. Current ratio is equals to N sub 2 over L sub 1 is equals to 1 over A. So, ito yung current ratio. And E sub 1 over E sub 2 is the voltage ratio. Is equals to N sub 1 or N sub 2 is equals to A. So we have here the relationship. If we are going to find the voltage ratio, it is equals to the turn ratio or the A. While if we are going to find the current ratio, it is the reciprocal of the turn ratio or the 1 over A. While the ohmic ratio, say sub 1 over say sub 2, is equals to A squared or the N sub 1 over N sub 2 open and close parenthesis squared. Here, the ideal transformer ratio, we are going to use it in a further discussion. So, gamit na gamit ito. Next, here is the exact equivalent circuit in the primary sides. Ito na yung i-represent natin yung actual apparatus into circuit. So, we are going to discuss the primary side First, we have here the V sub 1 or the effective applied primary terminal voltage, the I sub 1 or the effective primary current. Here we have the R sub 1 plus JX sub 1 or the primary leakage impedance. In transformer, common na itong R sub 1, itong primary leakage impedance. Meanwhile, after that, we have the E sub 1 or the effective primary voltage induced by the mutual flux. Under the mutual flux or the turns, so may mga turns na, we have the E sub 1 is equals to A E sub 2. So, E sub 1 is equals to A E sub 2. Makukuha natin ito dun sa transform ratio na the voltage ratio is equals to A or the turn ratio. We have here the I exciting or the exciting current. Exciting current represent the losses during the process of the transformer. Meanwhile, we have here the primary equivalent impedance. This A squared R sub 2 plus JA squared X sub 2 is the primary equivalence impedance. Makukuha natin ito dun sa, for example, in the step-up transformer, the resistance will be multiplied by A squared. This is the yung ohmic ratio. I-multiply siya sa ohmic ratio. Meanwhile, ganun rin sa reactance. Makukuha natin ito dun sa pag nagpa-process. Makikita natin dito sa diagram, under magnetic flux, yun sa turn, diba may mga turn pa yan na yan, pabilog-bilog na yan. Mga natin dyan na, may ma-generate pa dyan na, equivalent impedance, na primary equivalence impedance. So, doon natin mahanap yung A squared X, A squared R sub 2 plus J A squared X. So, after that, we have here the I sub L prime or equals to I sub L over A. I sub L is equals to effective secondary impedance. Current. Effective secondary current. Yung effective secondary current, makukuha natin yan sa using here. After that, we have the AB squared. AB squared. So, under halos the same lang siya sa A sub 1 is equals to A squared. However, it is under terms or sa process na nga ng converting. Next, we have here the equation or the formula for exciting current. Exciting current is equals to exciting or the impedance exciting and then E sub 1. Yung same, makukuha natin siya dito sa R0 tapos X sub N. Do the impedance. Next, the magnetizing current. Magnetizing current is equals to X sub M E sub 1. The magnetizing reactance multiplied by E sub 1. So, makikita na naman natin sa circuit. Makikita natin yun dito sa circuit kapag ginamitan natin ng Kirchhoff law. So, sa core loss current is equals to R0 multiplied by A sub 1. So, the core loss current is equals to A sub 1. Multiply natin sa R0. Yan. Makukuha na natin yung core loss current. Meanwhile, the exciting current using the nodal analysis, the core loss current plus magnetizing current is equals to exciting current. Makikita naman natin dito using nodal analysis. Dito, nodal analysis, kukuha na natin yun dyan. Then, if we are going to specifically get the core loss lang, walang current, we are going to core loss current squared multiplied by core loss current resistance or R0. Ayan, makukuha na natin yun. Under load, the primary current is the phasor sum. So, ibig sabihin, phasor sum, ito may angle-angle yan. I sub 1, yung using the nodal analysis ulit, I sub 1 is equals to I sub L prime plus I exciting. So, kita naman natin siya sa circuit na yung I sub 1 is equals to ito I sub L prime then exciting current. Next, here another formula for getting the I sub L prime. I sub L prime are equal to I sub L over A. So, under the step-up process, the step-up transform, the current, we are going to divide it to turn ratio. So, is equals to AB squared over square root of A squared R squared R sub 2 open and close parenthesis squared plus A squared X sub 2 open and close parenthesis squared. So, makuha natin yan na parang relationship na itong nasa taas. Parang ganyan. So, if we're going to find the angle, cosine theta sub 2 is equals to A sub squared R sub 2 all over square root of open and close parenthesis A squared R sub 2 squared plus A squared X sub 2 open and close parenthesis squared. So, yan, makukuha na natin yan dyan na yung theta or yung angle tapos yung I sub L prime. Then, where theta sub 2 is the load power factor angle. So, makikita na natin dyan yung kung lalaging or yung lagging. Next, in the secondary side. So, we have here the secondary equivalent impedance. Same siya dun sa primary impedance. Ang pinagkaiba lang is dito, i-divide natin siya sa ohmic ratio na A squared. So, R sub 1 over A squared plus A X sub 1 over A squared. So, in the secondary equivalent impedance, ginagamit natin yung R sub 1. Meanwhile, in ginagamit natin yung R sub 1 plus X sub 1 or the primary leakage impedance. Meanwhile, in in the primary equivalence impedance, ginagamit natin yung secondary leakage impedance na R sub 2 plus X sub 2. Yan. Next, we have here the A sub 1, A multiplied by A sub 1, or the primary current. So, yon. Diba, under process na nung transformer, meron tayong ma-generate na current. So, for example ulit, in the step-up current, or the step-up transformer, i-multiply lang natin siya sa turn ratio, yung current, para makuha natin. Meanwhile, the B sub 1, i-divide natin sa turn ratio. Next, we have here the losses or the exciting current. In the primary side, we have here the R naught lang. Here we are going to multiply to ohmic ratio na A squared in both sides, in the R naught and the magnetizing reactance. So, E sub 2 is equals to E sub 1 over A. Makikita natin to sa relationship ng transformer ratio na yung A is equals to E sub 1 over E sub 2. So, halos kaparehas lang yan, inuulit-ulit lang. Gamit na gamit yung ideal transformer ratio. So, we have here the secondary leakage impedance and the current. Yun the secondary current. Then, the output voltage na B sub 2. Here, we are going to the formula for B sub 1 is equals to R sub 1 multiplied by I sub 1 plus X sub 1, I sub 1 plus E sub 1. So, kung makikita natin dun sa dito, na para makuha natin yung B sub 1, gagamitin natin siya dyan ng Kirchhoff law. Yung i-Kirchhoff natin siya para makuha natin yung ito. So, pag Kirchhoff law natin yun, makakuha natin yung R sub 1 multiplied by the primary current plus X, the reactance multiplied by primary current, and then the primary voltage induced by the amplifier flux. So, same in the B2. Ganun rin. Aanahin rin natin siya sa Kirchhoff law. Then, magkukuha natin negative R sub 2 I sub L minus JX sub 2 I sub L plus E sub 2. If we're going to get the E sub 2, aano lang natin siya, ma-manipulate. Then, where the B sub 1 is the primary terminal voltage, B sub 2, the secondary terminal voltage, E sub 1, E sub 1 is the primary voltage induced by the mutual flux. E sub 2 is the voltage induced by the mutual flux. I sub 1, the effective primary current. I sub L, the effective secondary load current. R sub 1 and R sub 2 is the resistance of the primary winding and the resistance of the secondary winding. Then the X sub 1 and X sub 2, the primary leakage reactance and the secondary leakage reactance. Tapos na. So, maano lang natin doon na the transformer ratio, the exact equivalent circuit is the representation in circuit of the actual process of the transformer. Doon makikita natin na the torque or the transformer ratio dito makikita natin na yung under the magnetic flux, we have here the primary equivalent impedance. So, meron pa tayong makukuha na equivalence impedance under magnetic flux. So, kaya makasasabi natin na isang equivalent circuit siya if we represent the equivalence the equivalence impedance under magnetic flux. Yan. Next, thank you. Yan lang po.